This lecture is about factoring trinomials, and there's two parts to this lecture. The first part is we are talking about trinomials of the type ax squared plus bx plus c. So you notice that the coefficient of squared term is 1. Okay, so that's the first type. So let's write down the method before we do some examples. First thing you need to do is to break down bx, that's the middle term, into two terms with sum of coefficients being b and product of coefficients being c. So a lot of times we just say that the sum is b and the product is c. And next, we're going to be using either grouping or the shortcut. So let me show you what I mean. Take, for example, we wish to factor x squared plus 3x minus 10. So this is a trinomial. According to the method, you're supposed to look for two numbers so that their sum is 3 and the product is negative 10. The trick is you're supposed to use the product to figure this out. So ask yourself, what times what gives you 10, negative 10, but yet when you add them, gives you a positive 3. So if you think of what numbers give you 10, you could think of things like 1 times 10 or 2 times 5. Okay, so 2 and 5 has a chance of getting a positive 3, a sum of positive 3. So for the sum to be positive 3, you notice the 5 has to be plus and the 2 has to be the minus. So that positive 5 with negative 2 makes it positive 3. And yet, when you multiply them, it gives you negative 10. Okay, so there's always only one choice that will work. So if you can find such a choice, then that would be the two numbers you need. And what do you do with these two numbers? According to step 1, you're supposed to break down the middle term, which is in this case 3x, into these two terms. You're supposed to break it down into negative 2x and positive 5x. So instead of calling it 3x, you're going to call it negative 2x and positive 5x. Okay, and why do you want to do that? The reason is because we plan to use grouping, and if you recall, for grouping, we need to have 4 terms. Right now, the trinomial has only made out 3 terms. I can't use grouping. So by breaking the middle into 2 pieces, I now have 4 terms. And with 4 terms, I can now apply the grouping method, which requires me to put the first 2 terms in the first parentheses and the next 2 terms in the next parentheses. So in the first parentheses, we can factor on x, leaving us with x minus 2. And in the second parentheses, I can factor out a 5, leaving me with x minus 2. Now if you look closely, you notice there's 2 groups of terms here, and of these 2 groups, x minus 2 is common. So take him out. That's my GCF, and I start a parentheses for the leftover terms. So there's x, and there's plus 5. That's the reduced polynomial. So this is the method that was discussed in 6.1. Okay, so let's try another example. Can you factor, say, r squared minus 12r plus 27? So remember, the middle term is what gives you the sum. You need a sum of negative 12, and the back term is what gives you the product. So the product, you want it to be positive 27. And you always use the product to figure this out. So what numbers multiply to give you positive 27, and yet when they add, it becomes negative 12? So think of things like 3 times 9, except that you need to use negative 3 and negative 9. So that negative 3 times negative 9 makes it positive 27, and yet when you combine, it becomes a sum of negative 12. Okay, so there's a number that will satisfy both conditions. And so once it's decided what that number is, we break it into two pieces. Instead of negative 12r, that is right here, you break it into what's negative 3r and negative 9r. So you have your r squared and you have your 27. So the middle pieces was broken into two pieces. Now that we have four terms, we can now apply grouping, which says that you start two parentheses with a plus. R squared minus 3r goes into the first one. Negative 9r plus 27 goes into the second one. In the first parentheses, you notice r is common, so I took out the r, leaving me with r minus 3. Now in the second polynomial, you notice you have a negative term right here, so I'm going to factor out the negative and the 9, leaving me with negative 9r now becomes positive r, and to get 27, I need a minus 3. So the signs are switched. So now again, I have two groups right there, and r minus 3 is common. So factor it out. Start a parentheses, leftover term is r minus 9. So that's the answer for the first example, and that's the answer for the second example. So this method is what you call grouping. Okay, but the thing is, if you look closely, it seems that after all that work, our final result is x minus 2 and x plus 5. And that happens to be exactly the two numbers that we got here. Okay, minus 2, 5. Minus 2, 5. So he wonders whether it's coincidence. Okay, and you look at the second example. We got the trinomial. We found the sum and product. We found the two numbers to be negative 3 and negative 9. But you notice after all the grouping, the final answer has a negative 3 and negative 9 as well. So it is not coincidence. That is the answer. Okay, so now we're going to use a shortcut. So first and foremost, when we are given the trinomial, we will find the sum and product the same way we did here. And then the shortcut is using the two numbers given to you, straight away put them right in there. Same with this one. In the second example, we find the sum and product, and then we apply the shortcut, and we put the numbers right there. Okay, so think like that, and we're going to try more examples. Let's try example 3. Can you factor, say, y squared minus y minus 20? So first you look for the sum, and then you look for the product. Remember, the sum is the middle number. It's the coefficient that we're looking at. So when you see negative y, the coefficient is really negative 1. The product is given by the last term. In this case is negative 20. And you're supposed to use the product to help you. So what times what gives you negative 20, and yet when you combine them, it becomes negative 1 when you add. So you will find that the numbers are negative 5 and positive 4. So according to the shortcut, you're supposed to start two parentheses, and because the alphabet that's used here, the variable is y, so we're going to use y and y. And these two numbers that we just found, negative 5 and positive 4, negative 5, positive 4. We're just going to put them right in. So how can we check that we are correct? Okay, so we can always check bifoiling. So if you take y times y, that's y squared. Y with 4 makes it plus 4y. Minus 5 with y makes it minus 5y. So with these, you get your negative y, which is what we want. And finally, negative 5 with positive 4 makes it negative 20. So true enough, the shortcut does work. Okay, these are the two numbers that you have here, and you use them right there. So sometimes we do combine methods. So take for example, if we wish to factor b squared y to the 6 minus b squared y to the 5th minus 20b squared y to the 4. So at one glance, this question looks a lot harder than what you saw in example 3. But don't forget rule number 1. You have to look for GCF. So what is common? B squared, B squared, B squared, that's common. Between y6, y5th, and y4th, you're supposed to take the lowest exponent, which is y4th. So when you do that, your reduced polynomial becomes y squared minus y minus 20. So b squared y to the 4th is your GCF. Do not drop GCF. Very important. Okay, so some students, they just throw it away. You can't throw it away, but what you can do is copy it and focus on the trinomial here. So we are looking for a sum of negative 1 and a product of negative 20. So as seen in example 3, the two numbers are negative 5 and positive 4. So y and y, negative 5, positive 4. And that's your answer. So you notice that example 4 looks a lot harder than example 3, but that's because we are incorporating GCF in the question. So you do have to take out the term before things start to clear up. Sometimes we also confuse you by rearranging the terms. Say, for example, if I were to give you what's factor for r minus r squared plus 32. So you notice that you have to first rearrange them. So rearrange terms in descending order of exponents. So you have to put the r squared in the front, but bring the negative with you. So it's negative r squared plus 4r plus 32. Okay, and even that, you notice that in front of the r squared, the coefficient is a negative 1. And we had an agreement, if your polynomial begins with a negative term, you have to factor out the negative. So take out the negative 1, and that changes all their signs. So it becomes r squared minus 4r minus 32. It is this trinomial, the reduced polynomial, that we are looking for the factors. So the sum in this case is negative 4, and the product is negative 32. Remember to use the product. So what times what gives you negative 32, and yet when you combine it gives you negative 4. So you notice it's negative 8 and positive 4. Okay, so what's the final answer to this question? It's going to be r minus 8 and r plus 4. But there is a minus in front of it. And remember, you can always check by foiling. Okay, so r and r is r squared. R with 4 is 4r. 8, negative 8 with r is negative 8r. Negative 8 with 4 is negative 32. So that's r squared minus 4r minus 32. But don't forget you have a minus in front of the polynomial. And so when you distribute the minus throughout, you get your negative r squared plus 4r plus 32, which is how the question came right at the beginning. Yet another variation to consider, so let's call this example 6 actually. What if I asked you to factor y squared minus ys minus 20s squared? Now the difference between this and what you've seen is in this polynomial, it's made up of two different variables, not just one letter as two different letters. If you look into the context of one variable in terms of y, for example, you notice we start with y squared, and then we go to y, and we go to the last term that has no y. So this is in the correct order, is in descending order of exponents for one variable. Okay, so the sum we're looking for is negative 1, and the product is still negative 20. So you notice in all this, we're still looking at just the coefficient, okay, which is the number in front of the variables. Using the product, it tells you that the two choices are minus 5 and positive 4, because when you multiply, you get negative 20, and when you add, you get negative 1. Okay, so now we're gonna factor, and this is the difference. To get y squared, you have to use y and y, and then negative 5 and the plus 4 is being used there. But when you multiply the negative 5 and the 4, for example, you only get negative 20. If you want to get negative 20s squared, the difference is you're going to put an s on one side and s on the other one, so that when you multiply in FOILing, you will end up with y, that's y squared, y with 4s, that's 4ys, negative 5 with sy is negative 5ys, and negative 5s with 4s is negative 20s squared. And this together gives you your negative ys, which is what the question came with.